This is a video in which we will look at using data analysis techniques of the kind we've been learning, exploration, practical and statistical significance, to answer research questions with two variables. In this video, we start with going back to the beginning. In the beginning, we looked at the different options. We will be looking at exploration, practical significance, which we've done already in Stat 1013, and today, with two categorical variables, we'll be introducing inference and hypothesis testing. To the right, you see a SPSS screen, so we will also be investigating how to do that with SPSS. What are the options with two variables? We can look at two measurement variables. Think about what's the shortcut for the analysis? Correlation. With correlation, we measure strength and direction. Visually, we look at a scatter plot. Two categorical variables. Take 10 seconds and think about it. Okay, we look at contingency tables, comparing rates, comparing proportions, comparing ratios, likelihoods, probabilities. There's various ways to call that, various things we can call that. That's the numerical. Practically, we look at relative risk or risk difference. And visually, we look at comparison pie charts. That's the best. One categorical, one measurement. Take 10 seconds and think about it. Yes, compare means. Raw difference, percent difference, Cohen's d, numerically. And we look at comparison box plots and paneled histograms, visually. Today, two categorical variables. Okay, comparing proportions, rates, probabilities, likelihoods, like we said. We look at contingency tables, paneled pie charts or bar charts. I would not recommend those. Those are a possibility though. Practical significance, we look at relative risk or ratio of rates, that could be also called, and risk difference. Hypothesis test will be chi-square independence. This said test of two proportions, that will be in other textbooks or courses. Whoops. Today, exercise B. Immigrant status is one variable. Dwelling owned by member of household is the other variable. And you see them here. Dwelling to the right. Dwelling owned by member of household and immigrant status right there. Research question. Are immigrants to Canada as likely to live in a home owned by a member of their household as non-immigrant Canadians? Interesting question. We have real data. So we open up the data set, which is in statras.com, and we're going to explore the data, calculate relative risk, risk difference, and then do a hypothesis test. Here's exploration. You'll see the contingency table here. You see comparison bar chart, which you don't need to do. It's not very useful. And paneled pie chart. So let's produce those using SPSS to the right. Analyze. You will go to your SPSS instructions booklet on page 10 for the exploration. We go to crosstabs, and I've already done this before, so it's pre-moved in here. The independent variable goes into rows. The dependent variable goes into columns. So remember that. This is the independent variable. And this is the dependent. And remember, we know that by the research question. So we go back to the research question. We say, well, which group, immigrants or non-immigrants, are more likely to own their own home? So what you see here is bare bones contingency table. What I'm going to produce here is, sorry, let me get the pen off, is one where we're doing percentages by row. Because we have independent variable by rows, we do percentages by rows, and so that's going to produce this table with percents. I'm also going to produce the paneled pie chart. And oh yeah, that was here, ponder pie. Again, you follow your SPSS instructions, click, click, click. Independent variable this time goes into columns because we want it set up in this way. And the interior is divided by the dependent variable, which is whether the dwelling is owned by a member of one's family. And so here will be produced, click, 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 and we have it here. Now, what do we do with all this? Well, you can read what the text there. What we see is that they're pretty similar. So both groups have very similar, right? Dwelling owned by member of household, that's the yes part here. Similar size. That means rates are similar. And that would be the rates of home ownership. Here we have a larger table, and that's the one with percents. And so what we have here, we have this is a key rate, and this is a key rate. This is what we're comparing. This is how we get this 3.4%. Right? So when we look at non-immigrants, these are the Canadian-born, 74% of them. So 1272 divided by 1701. These are, remember, contingency tables. If you're struggling with this, you'll need to spend time to review the contingency tables, the workings of the contingency tables. So we're comparing the rates of home ownership in non-immigrants to immigrants to Canada. Okay, so yes, 167 over 234. And we'll see the next slide. We'll break this down a little bit for us. All right. And so let me just write that out here quickly. So this is 167 over 234. This is 1272, 1272 over 1701. That's how we get these numbers, or that's how SPSS got these numbers. So make sure you're keeping that in mind. This is the likelihood ratio, which is the same as relative risk. Note that I'm using all the different terminologies, intermixing them so you get used to the fact that they will be different, and different people will call them different things in different situations. So the rate of ownership in immigrants, 71.4%, and non-immigrants, 74.8%, is very similar. And when we divide these two numbers, so note that I'm dividing the larger, right, by the smaller, and then I'm saying non-immigrants, because that's this one, right? They're 1.0476 times as likely as immigrants. That means it's pretty close to 1. And when it's close to 1, that means they're the same. So, just analyzing in exploration, what we see is there's not much difference between the rates of ownership. Non-immigrants in this sample are 1.0476 times as likely to live in a dwelling owned by a member of their household. Inference. So, all right, so now we get into the more complicated part of the process. Well, not really the more complicated, because technically all we're doing is pushing buttons and getting responses back. So, two variables are null hypothesis, which we always start with, is that there's no difference. So we can, in this kind of situation with two categorical variables, this is the style of null hypothesis that you will see. Two variables are independent. immigrant status is not associated with whether a dwelling is owned by a member of one's household, or immigrants are just as likely as non-immigrants to live in a dwelling owned by a member of the household. So those are two styles of null hypothesis you'll see when there's two categorical variables. So this is the output from the Chisquared Test of Independence, which is the one you will use. How do you know that's the one you will use? Because on page 15, inference with two variables, that's what we see. So let's go down and do that. So we go to the same crosstabs that we went to before. And now instead of the cells, we go to statistics. Under statistics, we look at the chi-squared. That's the chi-squared test of independence. There's a whole bunch of other ones you could use, but we're going to focus on the chi-squared test of independence. And off we go. And this is what, so we produce that table with percents by rows, but we also produce, we produce the chi-squared test. All right, so that's the one that's important. And so let's look to the left, to PowerPoint. And so I've highlighted where the p-value is. These other, let me just get the pen on. These ones are other tests. Okay, remember I said we're ignoring a lot of the detail in these statistical tests. So we're not worried about any of these. All we're worried about is the Pearson chi-square test. And what we get for the p-value is greater than 0.05. The next step, we're back. And we're going to look for the confidence interval for pure risk ratio. There it is. And what do we need? How do we use that? Well, we have to go back to the slide. Here it is. So we have immigrant status, yes, no. Exposure, let's call this yes, no. Okay, so 167, 67, 1272, and 429. Okay, so we've entered, essentially died is like dwelling owned by household, and exposure or independent variable is yes or no, right? And we can even, if we want to for ourselves, we can change that, right? Immigrant status, yes, no, and we can change this to dwelling, yes, no, just so we're not confused. Okay, and so what we see is, we'll see that 71%, 71.4% versus 74.8%, which is what we had back here, 71.4 versus 74.8. Note that in this, remember we talked about observed versus expected. So this is observed versus expected. So this is not the percentages table here. And we look, so the Excel file, we look at the relative risk. And this is the one we found because we said the no's versus the yeses. So 1.048 more times likely. And now these are all the calculations and this is the output. So when we were looking at comparing Canadian-born Canadians to non-Canadian-born Canadians, this is the lower bound and the upper bound of the confidence interval for the relative risk. And so that's where these numbers are coming from. Okay, so for looking here, so that is coming from here, and that is coming from here. So a relative risk of 1 indicates that immigrants and non-immigrants are exactly the same in terms of home ownership. The result here indicates that it's possible that immigrants are more likely, less likely, or equally likely to own their own dwelling. This does not contradict what we saw in the exploration. What do we say? What do we have here? What do we find? There's no evidence that there's any association between the variables. We've mentioned the 95% confidence interval for the relative risk. P-value, we mentioned, and we give the exact value. The differences between the two groups in this sample were very small. Based on the hypothesis test, I cannot make any statement of difference between immigrants and non-immigrants with respect to residents in a dwelling owned by a member of their household. A lot of words. There is little practical difference in the sample. It seems that each group is equally likely to live in a home owned by a member of their household. So what's the answer to the research question? There's no evidence that immigrants are more or less likely to live in a home owned by a member of their family. And I give the numbers. And remember that the confidence interval is much more meaningful because it's dealing with practical significance, not just statistical. P equals 0.262. Okay. But the confidence interval tells us a lot more once you get a good feel for the relative risk. Well, I'm not going to, since the video is long enough, I'm not going to get into two categorical variables both with greater than 2 categories, except to skip along here. So this is exercise 8C. You're going to do exactly the same work, except it's a lot. If you look through the video here, you can see we're dealing with 4 or 5 categories by 4 or 5 categories. Exploration is a lot more complex and messy, and so what we look for is, that's where that chi-squared test is really helpful for us, because what we find is, oh yes, there is a statistically significant difference between the groups. We can't do confidence intervals because the confidence interval setup that we have is just for a contingency table that's 2 by 2. And so we have to put our trust in the p-value. Or we have to spend a lot of time playing around with all the different categories. Good luck with exercise 8C, and thank you for watching.